For thousands of years, the world's oceans have held a special place in our imagination. Without them, life would never have come about.
We're only really waking up to how important the ocean is for life on this planet.
Today, some 4 billion years after they formed, our oceans continue to dictate life on Earth.
Oceans are absolutely critical. There's billions of people around the planet who are dependent on the resources that we get from oceans.
But this most precious of assets has never been under greater threat. As the human population nears 7 billion, so our oceans are struggling to cope.
It's quite clear that humans have had a profound impact on this ecosystem. We are talking now about an unnatural ocean.
If we have massive changes to the oceans and how they function, it could have really direct impacts on humans and their societies.
With time running out, marine scientists around the world have been working as never before
75 in the water, we're fishing!
to save this vital ecosystem.
We really do risk losing species before we've even been introduced to them.
But is it too late?
The living ocean is very fragile, and don't for a minute believe that we can't screw it up much worse than it is today.
Spread over an area of 360 million square kilometres, the world's oceans cover more than 70% of our planet. So large is their volume that almost all of the Earth's available living space consists of water. It's one of the great contradictions of the oceans that although they lie all around us, they remain the most mysterious of the Earth's ecosystems. What's living just out there is hidden from the sight of most of us. But in recent years, our understanding of this vast habitat has begun to increase, thanks in part to one of the most ambitious, inspiring, not to say timely, scientific projects of my lifetime. Called the Census of Marine Life, its goal has been to compile the most comprehensive list to date of life in our oceans, from the largest of mammals to the tiniest of microbes.
There have been few explorations of the ocean on a par with the census. The only thing that I can think of that really is like that are the great exploratory voyages of hundreds of years ago.
Involving over 2,000 scientists from almost 90 countries, it's used the latest technology to explore and document some of the ocean's most remote regions.
There's never been as big a project looking at the natural world. And we census human populations. We understand about how many trees grow on the land, but we've never ever had a baseline survey of what actually lives in the oceans.
Literally, the oceans are the support system for all life on Earth. And if you don't care about the oceans, then you're basically saying, I don't care about what happens to life on Earth.
What the census amounts to is a completely new biography of this, the largest habitat on Earth. Not only has it increased our knowledge of what lives there, but it also enhances our understanding of how that life keeps the planet alive. Today, the health of the oceans is in danger as never before, and it could well be that the census could prove to be a vital tool in safeguarding their future. For the last 5 years, marine biologist Dr. Julian Cayley has been overseeing a unique project whose results have formed an invaluable part of the census. The aim of this project? To catalogue the diversity of the most complex ecosystem in the ocean, coral reefs. A task so huge that it has called for a new and innovative way of collecting evidence. This morning, Julian is heading out to a long, thin stretch of coral reef called Ningaloo in Western Australia to recover some of that evidence.
Coral reefs host more biodiversity than any other system in the oceans. People can appreciate the diversity in rainforests, but we don't know about the diversity of reefs to the same extent. And it's because we haven't had the opportunity to get out and actually start sampling all that biodiversity.
Together with dive buddy Greg Coleman, Julian will be descending to a depth of 10 meters to retrieve a small plastic box that's been attached to the sea floor for the past 12 months.
Okay, this is what we're out here today to collect. This is what we call an ARMS. It stands for Autonomous Reef Monitoring Structure. It's a simple design that we can replicate, and the purpose of it is to provide some structure that we can take these down, we can put them on the reef, and things will come and live in them.
A simple but ingenious design that has helped Julian and his team to retrieve countless thousands of specimens from the seabed. After a thorough search of the area, Julian and Greg eventually find what they've been looking for, quickly covering the arms with a second box to prevent any creatures inside from escaping. And with the arms safely on board, the team head back to the lab. Just a stone's throw from the shoreline, the low-tech surroundings of a rundown sheep station double up as a makeshift laboratory.
We might just need a bit more water in there. This one looks like it's got maybe a bit more life on it than some of the previous ones we've pulled up.
Here, work gets underway, dismantling the reef monitoring structure.
We want to get everything out of it. There might be a few creatures still living in there.
So far, the project has recovered almost 200 of these boxes, each one containing a cross-section of reef life.
As we dismantle these, we could expect to find anywhere up to hundreds of different species, lots of which probably would be invisible to the naked eye, but the taxonomists can identify with a microscope later on. Leaving brittle star.
We find a whole range of different life, from the algae, the crustaceans, brittle stars. There's obviously the colonial animals like the corals and the soft corals and the bryozoans. It's a real snapshot of the biodiversity of the place.
But collecting all this biodiversity is only the first step. The next is to identify it.
Every time one of these boxes come up, or coral rubble samples come up, it's an adventure. There are so many different tiny invertebrates that live in the cracks and crevices of algae and corals. These animals I work with, these polychaete worms, are very small, sort of 1 to about 10 millimetres. Within this genus, there's only one species that has been recorded in the 1970s. I so far have found 22 new species belonging to this genus, Chrysopetallum.
I focus on the seaweeds and the algae. In algae, I work with macroalgae, and we go dive and snorkel and collect everything we find. So far, I think we have 7 new species.
We're part of a group with the Census of Marine Life who's looking at marine parasites. And what we look at are the parasitic organisms that live in the internal organs and the tissues of various reef fish. Just about every day we'll find a new species. There's a lot of work to do, many, many lifetimes.
To date, the Coral Reef Project has identified more than 1,000 likely new species. A number that rises to an estimated 6,000 across the census as a whole.
The census has really uncovered not only new species and new life forms, but just new understanding of where they live and how they live. And so it's everything from microbes to understanding connections between small crustaceans to finding new species of fish and squids that have been quite remarkable. I mean, it's literally thousands of new species in dozens of new environments.
But as these remarkable discoveries are enhancing our knowledge of what lives in the oceans and where, time is passing only too swiftly. It's one of the ironies of marine research that as we discover more and more about the oceans and what lives there, more and more of it is disappearing. And the reason for that, of course, is us.
I think all the threats to the ocean at the moment are man-made. There's no question that humans are ecosystem engineers now.
Recent studies have found that there aren't any places left on Earth where humans are not impacting the ocean environment.
And there is perhaps no single human activity that poses a more immediate threat to marine diversity than commercial fishing. But with an increasing human population, more and more dependent upon the oceans for our food, how are we to control how much we take from them? Here in the fishing port of New Bedford in Massachusetts, the nature of the problem soon becomes apparent. Like many other communities in this part of the world, fishing has been a fundamental part of daily life for hundreds of years.
Do what you can, get us as much as you can, and we'll go from there.
At the local processing plant, table fish such as cod and flounder are descaled, filleted, and packed up for markets throughout the world.
50,000 plus for Monday. Beautiful, beautiful.
The company has been run by the Barry family for the last 100 years.
Welcome to the Pear Fish Company. We employ approximately about 100 people. My grandfather started the business in 1910 in the waterfront of Boston. Snow White. Just like my baby's butt when he was born. Okay, beautiful.
Every day, up to 90,000 kilograms of fish pass through these doors. A seemingly never-ending conveyor belt of marine life. But appearances can be deceptive, because while stocks might look plentiful, companies like Pearfish are now having to source that stock from further and further afield.
What's the update on the Courageous as of today? He's fishing in the Barents Sea. Good, Chris, good, good. We appreciate that, we appreciate that.
From 100% of our production from domestic markets, I'd say right now it's about 15%. The rest is all imported from out of the country or other parts of the country. These days, everything's coming in by factory trawler, by rail car, over the road by truck. It comes from China, it comes from Indonesia, it comes from Vietnam, Russia. Products coming from all over the world now.
While some of this change can be attributed to the demand for ever more exotic species, it doesn't hide the fact that fish stocks globally have been drying up for decades. And what's brought this about is technology. combination of giant factory ships, high-tech sonar, and nets as long as 60 kilometers have enabled us to plunder the seas at will.
Air transit and styrofoam cooler boxes have made any kind of living creature from the sea available anywhere else in the world in 24 hours. And it's that sort of pressure that is simply not sustainable going forward.
Confronted with this technological onslaught, many species have reached the point of collapse. In 2003, researchers from the census published a paper in the science journal Nature comparing fish numbers with those of 1950. What they concluded was that in a little over 50 years, 90% of top predators, such as tuna, shark, and marlin, had been fished from the sea.
It's a predictable pattern in a sense. Things that reproduce very slowly are likely to be more vulnerable if they're under intense fishing pressure.
And it's a pattern that has consequences for all ocean life, owing to the nature of the marine ecosystem itself.
A lot of people would be familiar with the term food chain. It's one of those things that is very evocative of, you know, the little thing that gets eaten by the bigger thing gets eaten by the even bigger thing. But in reality, most marine systems are much more like a food web. What you end up doing is if you take out a whole bunch of the individuals from a particular level in that trophic web, you can affect change within the rest of the web.
And not necessarily change for the better.
We can't imagine that these systems function in a linear way. They just don't. And so we don't know if you push here, what actually happens there. We do know that if you keep catching all the fish, shooting all the whales and seals, netting all the birds, and taking them out of the system, ultimately you'll be left with copepods and bacteria and some other things that won't make the picture as pretty.
In one of the most disturbing pieces of research commissioned by the census, the question was asked, how much longer can our oceans tolerate the present level of commercial fishing? The answer was simple and stark. If present trends continue, commercial fishing as we know it will have collapsed by the year 2050. An outcome so catastrophic that marine scientists have been at the forefront of efforts to manage remaining fish stocks before some species are lost for good. Massachusetts Bay in the Northwest Atlantic.
U.S. Coast Guard Sector Southeastern New England out.
Okay, you're good to go.
On board the fishing trawler Gloria Michelle, her crew are letting out their first net of the day. Just another fishing vessel going about her daily business.
Last 25!
But what sets this boat apart from the vast majority of other trawlers is that she's using a type of net that has been declared illegal. Made from a very fine mesh, its sole purpose is to catch whatever is out there, regardless of size. First mate Carl Rhodes is hopeful it will ensure a good haul.
Sometimes we catch big torpedo rays and some of the larger animals too. Sculpins, sea robins, just all kinds of fish that live closer to the bottom.
At 50 meters down, the winching mechanism comes to a halt.
75 in the water, we're fishing.
And the wait begins. On a given signal, the net is finally hauled in. But as its contents spill out onto the deck, it's clear that this will be no bumper payday.
The last 3 days, all the catches have been a little light.
Sculpin. Lighting.
While a catch this small would normally be a disappointment, for the Gloria Michelle and her crew, it's not a concern. Because she isn't out here to turn a profit. Instead, she's fishing for an altogether different reason.
Who's got the little whiting bucket?
As part of a scientific survey of fish stocks in the area. For scientist Matt Camisa, it's vital that each trawl is exactly like the last.
The most important thing we do is we do the same sampling technique, the same methods, the same gear, consistently. Consistency is the key. If you keep it consistent, you can look at the trends over time and know that you haven't influenced that trend.
2 hours later, the Gloria Michelle is in position over her next survey site, and the whole process begins again.
These are winter flounder, a common ground fish. A lot of people fish for these around here. So what we're going to do is, now that we have the weight on all of these, we're going to take the lengths on all of them. Some of them have to be sampled. We're going to cut them open, determine the sex and maturity. These are the otoliths, or the ear bones. They have rings on them, like rings of a tree. That's what they use to age them.
Determining the age of each fish is crucial to the survey, because only by getting an idea of juvenile numbers can the scientists estimate how plentiful fish stocks will be in the future.
All of our data, the state inshore trawl survey data, gets fed to the federal database, which is used to do all these stock assessments on all these various species. And after they've done all these stock assessments, they make the management regulations and all the decisions on what fishermen can and can't do, when they can catch them, how much they can take. That's very valuable.
So valuable that some species have actually begun to bounce back.
Certainly some stocks have rebounded. We've had a good rebound in our fluke resource. That's not something we're seeing here today, but the yellowtail resource is doing quite well also. Well, it's a mixed bag. You know, some species have gone up and others have gone down.
In fact, it's been estimated that in American waters, where management strategies have been implemented, almost 50% of fish stocks have shown some sort of increase. But while this might be grounds for hope, it raises another question, which is exactly how productive should we expect our oceans to be? A question to which the answer lies back in time. Professor Jeff Bolster has been part of a census-led project documenting the history of commercial fishing in New England.
Caught 4,760 fish. Caught 1,600 fish. 2,300 fish. Caught 1,000 fish. Caught 5,500 fish. Caught 3,020 fish. 4,000, 7,000, 80 fish. 100 fish. It's impossible to imagine the coast of New England without imagining commercial fishing. I mean, this is the oldest profession in America, and it's one that is threatened today, but it is woven into these communities in a way that is deeply, deeply part of their essence.
By trawling through the historical record, Jeff has become convinced that the key to the future productivity of the oceans lies in the past.
Every European that came here wrote with astonishment about the nature of the ecosystem. And the point is that they weren't comparing it to the Caribbean or the exotic East Indies where all the fish were different. They were comparing it to their own backyard. It was salmon and herring and skate, everything they were familiar with, but the numbers were colossal.
Just how colossal is apparent from even the most cursory examination of the record.
Monday, 4th day of July, 1859. This day begins with light winds and calm and continues throughout the day. Thus ends the glorious 4th by all hands toiling hard in fishing and caught 2,700 codfish. This is the log of the schooner Mahalia from Newburyport, just down the road. They're catching cod. The numbers are phenomenal. They've come in to spawn, and then once the spawning is done, these men are catching them. The daily catches here for each man, I mean, we have one man caught 472 fish, another man 461, 403, 410, 390. So again, this is a significant number of fish.
Using these historical figures, Jeff has been able to compare past cod numbers with present.
The annual catches today in the entire Gulf of Maine are about 4,000 metric tons, if you exclude the recreational catch. But in 1861, 70,000 tons, hand lining, little sailboats. Today, 4,000 tons, big modern steel ships, electronic fish finders, navigation systems. So the system has changed profoundly.
By showing the marine ecosystem as it once was, Jeff hopes to change perceptions of what constitutes a healthy fish population today.
I mean, if you imagine sort of the pathetic graph of fish landings is that it goes down, 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 down. And around 1990, around here, it bottoms out, and now there's an uptick. Okay, there's an uptick, and it's good. And what people sometimes say is, well, look, there's more fish now than there used to be, because they're talking about now compared to 20 years ago, right? But they need to think about the scale. The uptick is tiny, and what we've had is this huge descent. And what our group is doing, by providing that historical perspective, is saying we need to look at this ecosystem through time.
But setting targets based on the number of fish that used to live in the oceans doesn't mean that we can just expect to turn back the clock.
We don't know if it can be as good again as it once was. We don't even know if it can be as good again 100 years out as it was 100 years back. But to not try, I think, is really short-sighted.
We don't want to think about, managing the environment as if we're going to go back to some pristine state or even go back to, the conditions 100 years ago. Ecosystems change, human activities change, and so on. But that doesn't mean that we should ignore at least the potential for oceans to produce, a greater abundance of fish.
Whether or not the oceans can ever again be as productive as they once were is a question that scientists can't yet answer. But they are sure of one thing. If we are to save the commercially important species of fish that are currently under threat of extinction, we must act with the data we now have. Do nothing, and the implications are inevitable. The loss of dozens of species of marine fish around the world. But on the other side of the world, there are habitats that are facing a threat, the implications of which scientists are only just beginning to work out. At the southern tip of Australia's Great Barrier Reef lies the tiny coral key of Heron Island. A designated national park, its crystal clear waters have been attracting tourists for almost 80 years. But these waters also contain clues which suggest that by the time another 80 years is up, they will have changed beyond all recognition.
Well, it looks like it has survived the night.
Today, Professor Ove Hergelberg from the University of Queensland is launching a unique experiment to monitor how this change will affect coral reefs. In 2006, Ove took part in a BBC documentary following the effects of global warming on the reef.
When I come here and see this really stressed out reef, I find myself getting really concerned. It's another reminder that there are huge changes on the way with climate change. Everywhere I look, all I can see is bleached corals. Corals that are normally brown are now glowing a brilliant white. This is because of the algae having left the tissues. All that's left are the absolutely reflective skeletons. 4 years ago, we were looking at the impacts of temperature on coral reefs, and that's where we've had rising ocean temperatures and mass coral bleaching, and it's threatening the entire ecosystem. But since that time, there's now the realization that there are even larger forces at play, and that these forces are combining with things like temperature to make a very gloomy future for coral reefs.
The cause of this new concern is an environmental impact with the potential to be every bit as disastrous for reefs as rising sea temperatures. ocean acidification. For billions of years, the oceans have played a vital role in keeping the Earth's carbon dioxide levels in check.
The ocean's involved in a huge conveyor belt, a sort of a chemical reactor, if you like, in which CO2 goes into the ocean, it's fixed by plants, it may be deposited as calcium carbonate, and through these very, very large-scale circulations of water on the planet, it's essentially processing the atmosphere and keeping our planet habitable. And of course, we're only just starting to realise that this is actually what we live off. It's the ocean.
But since 1960, carbon dioxide levels in the atmosphere have risen by almost 20%, and by roughly 30% since the start of industrialization.
Like all things, oceans have a capacity. So as we've been pumping CO2 into the atmosphere by the burning of fossil fuels, we've actually started to exceed the capacity of the ocean to absorb that carbon dioxide.
One byproduct of this increased CO2 in our oceans is that they are becoming more acidic.
When carbon dioxide goes into seawater, it reacts with water molecules to produce an acid. And that's something we can actually show here. Seawater around the planet has a pH of probably 8.1 to 8.2. Now what I'm going to do is I'm going to use the CO2 produced in my body to blow into the seawater and essentially simulate what would happen if we started to change the CO2 content of the atmosphere. So I'm just blowing air from my body that's got lots of CO2 in it. And after a while, we'll see the pH value start to drop. And the lower this is, the more acid the water is. There, so it's starting to drop right now. The value on the pH meter has dropped from 8.2 to now 7.9. Now, that happens to be the equivalent of what would happen to seawater if we doubled the concentration of carbon dioxide in the atmosphere. Now, it's not just the extra acidity of the seawater that's a problem. The fact that we're blowing carbon dioxide into this solution also changes the concentration of a chemical species known as carbonate. Now, that carbonate is what corals need to build their skeletons.
It's to predict how acidification will affect this ability of corals to grow their skeletons that Ove and his team have built their experiment.
You can see the pH dosing water comes in here. So this is low pH water, and it goes into 4 points that have holes going all the way down.
For the first time anywhere, they will be subjecting sections of living reef to different concentrations of CO2.
What's really neat about this experiment is you've got corals growing as naturally as possible, but under different atmospheres of CO2. And you've got to have replicates. So we've got two that are at today's setting, and then two that are really one of the worst case scenarios where we continue to build up CO2 and we'll see as much as 1,000 parts per million above coral reefs. Now, from the laboratory, we've got very good information to say that that's going to do corals in, but we're trying to do it here in nature with these different conditions in these different chambers.
Today, the system goes online. But first, each chamber must be hooked up to a control module whose computers will help maintain precise water conditions 24 hours a day.
I was thinking it's a little bit like a lunar lander. We're hoping to go for ecologically relevant lengths of time, which is hopefully a year. And that's, hopefully we'll get the seasonal cycles, we might even see bleaching events, all sorts of interactive phenomena. So we're hoping for that, but that's going to be a challenge because no one's really ever run an experiment like this or for any length of time.
For the scientists, this moment is the culmination of many months of hard work.
Only 2 years of your guys' life, we can start again, can't we? I don't think so. 1, 2, 3. Find the coral. Just be careful not to fall over. You're coming with a coral there.
A few hours later, and the underwater lab is up and running.
All our instruments are online, and as we see the data that each of the different instruments are giving us, we can see that we're monitoring the chemistry in the environment, so we know exactly what's happening with the chemistry on the reef flat, and at the same time it gives us the ability to see how successfully we're recreating these future CO2 conditions that are predicted for 50 or 100 years. And you can watch the chemistry change before your eyes. It's pretty exciting.
But if this experiment does indeed confirm what many scientists are predicting, what does that mean for places like the Great Barrier Reef?
Already at the concentration of CO2 we have in the atmosphere, we're already seeing very large responses from coral reefs. We're seeing large-scale mortality events, and scientists are now recording the decline in the calcification that's going on reefs, and this is not seen in hundreds and hundreds of years of records. So if we go forward in time, we may see reefs degrading, such that over time we'll lose these great wonders of the ocean.
All of which raises the question, what can be done to save them?
So there's really two things we've got to do. The first is we've got to limit further increases in CO2 because we know that those futures don't have corals in them, will rapidly exceed the known conditions for coral reefs. But the second thing we've got to do is treat reefs better on a local scale. We've got to reduce the overfishing, we've got to reduce the pollution, the sedimentation and so on. And if we do that, we will have coral reefs survive this century.
One of the key responsibilities of scientists is to really provide the evidence of what's happening and put it in a format so that people can realize the impacts that CO2 emissions are going to have and convince them that if they don't do something about how they live day to day, there's going to be real consequences for the oceans and for the whole planet.
To my mind, acidification is the greatest threat facing oceans today. Even if we stopped our carbon emissions now, it would be many centuries before the oceans returned to full health. But humanity is damaging the ocean and ocean life in ways which are very surprising and which we're only just beginning to understand.
The depths under here, it's showing that we've just come down off the bank, come off the edge, and it's getting deeper now.
Stellwagen Bank National Marine Sanctuary, some 30 nautical miles off the eastern coast of the United States.
Very productive area, of course, that edge of that bank. Feeding frenzies up there with 4 or 5 different species all entangled.
Marine biologists David Wiley and Denise Riesch are scanning the horizon for signs of one of the largest animals to live in the ocean.
That's some really nice open mouth feeding over there. You can see 4 or 5 animals all working together.
The humpback whale.
These are humpback whales. They're an endangered species, one of the real common animals found in the sanctuary. Although they're endangered worldwide, this is really a hot spot for humpback whales.
There's more open mouth feeding over here. For me, this is one of the best feeding aggregations I've ever seen. I think we're having probably 15 to 20 humpback whales in the area, all actively feeding.
But despite this being a marine sanctuary, the humpbacks don't have these waters to themselves. And that's because Stellwagen sits in the middle of one of America's busiest shipping lanes.
On a yearly basis, we've got about 500 different vessels and about 4,000 transits going through the sanctuary. And what you're going to see here is a day-by-day plot for 1 month of that activity. So each one of these black lines you're seeing is the track of a vessel as it goes in the sanctuary. You can see those prop marks right along that tailstock from the animal. That's from being hit by not one of the big ships that we've been working with, but from smaller, more pleasure craft. You can see the prop marks running right up the side of the animal. So they're also a risk out here they're trying to deal with.
It's to help avoid these collisions that David has been working closely with scientists from the Centres of Marine Life on a new method of tracking whales, not on the surface, but underwater. The system employs sophisticated sensors called D-tags that are attached to the whales using suction cups.
Perfect! Oh, beautiful. Perfect.
After a set time, the tags detach themselves and their data is downloaded.
Once we get the tag data back, we download it into this program called TrackPlot, and it was designed specifically for us to visualize our whale data. What's been really exciting about it is, for the first time, it's allowed us to really function like terrestrial biologists, where we can watch an animal from the beginning of a behavior to the end, whereas before all we could watch was an animal taking breaths at the surface and then disappearing.
By plotting these movements, the scientists have been able to identify those parts of the sanctuary with the most whale activity, so enabling them to redirect shipping and reduce the number of collisions. But this new technology has also allowed them to monitor another crucial aspect of whale behaviour. Travel down into the ocean, and gradually the light begins to fade. At 200 meters, almost all the colours of the light spectrum have been absorbed. By 1,000 meters, any light has disappeared completely. At these depths, eyes are of little use. Instead, this is a world of sound. A world that whales have evolved to make their own.
Humpback whales are one of the probably most vocal marine mammals and the best well understood. They use sound kind of like we use our vision. They use it for to navigate. They use it to find food. They use it to keep in touch with each other and to find mating partners. So basically, all their basic life functions are governed by sound.
But in confirming the importance of sound to whale behaviour, the scientists have discovered something else. That this vital means of communication is in danger of being drowned out.
One of the issues that we're trying to work with at the sanctuary is this idea of the impact of noise on the marine environment and on large whales in particular. So you're looking at a bunch of dots down here, and those dots actually represent right whales that are calling. The color that you're seeing is really a gradation of how intense sound is. So a very bright, like red, is going to be a very loud sound, and then if you get down to blue, that's a much softer sound. If you can see very nicely the right whales now, but as the ship goes by, you'll see they disappear into the coloration. Anytime they're disappearing, that means that their sound is being masked. They're not going to be able to send information from one animal to another.
With noise pollution doubling every 10 years, David believes this masking could be having a significant impact on whale behaviour.
The animals are making sounds to communicate. Now, they may be communicating their presence, they may be communicating the presence of a food source, but they're trying to send information from one animal to another. When ships go by, they're unable to pass that information.
But some scientists think that ocean noise is affecting whales and other marine mammals in an even more fundamental way. Here at Woods Hole Oceanographic Institution, 80 kilometres south of Stellwagen, a group of scientists are carrying out research into the complex hearing mechanism of marine mammals. The work is being led by Dr. Darlene Ketton, a world expert in not only animal but also human hearing.
We have a large body of knowledge about how humans lose hearing and exactly how certain conditions affect hearing. We're taking that information now and applying it directly to whale and dolphin ears.
Like the scientists at Stellwagen, Darlene also has concerns about the effect ocean noise is having on these animals.
For whales and dolphins, it's very much like our living next to an airport with planes going off 24 hours a day, living next to freeways with traffic jams constantly, living in a factory with lots of pounding machinery going on 24 hours a day.
This morning, she's looking for physical evidence of how such noise may have affected the hearing of this dolphin, found washed up on a local beach. A process that begins with a highly detailed internal scan.
CT scanning is a phenomenal tool. Modern imaging lets us actually look at something at levels of detail that you could not do normally without dissecting and slicing down to thin slices mounted on slides. People like Da Vinci would have loved this because you get to see the whole body as well as micro parts of it. That might be a calcified cyst.
Millimetre by millimetre, the dolphin's medical history is gradually revealed.
We've got some lung collapse over there, maybe disease. His heart's a little enlarged. Okay, let's change our parameters and focus on the ears.
Switching attention to the dolphin's internal ear structure, it's quickly apparent that all is not as it should be.
What we're looking at here is the whole head at 0.5 millimeter slices. On both sides, there's some loss of tissue at the inner ear, especially in the nerves going to the ears. Here we can see that there's very little nerve in this region. This should be filled with tissue, and there's actually only about 50% of what we'd expect to see, which would have made it very difficult for this animal to hear normally.
While Darlene accepts that this type of hearing loss can have a number of causes, her experience of not only scanning marine mammals, but also dissecting them, has convinced her that ocean noise is also playing its part.
We are seeing ears from animals, particularly in very noisy areas like the North Atlantic and the North Sea, that have hearing loss clearly related to noise. It's throughout the entire inner ear, but equally important, the rest of the auditory system also shows some damages that suggest that they are under stress from the noise, which is an important part of noise effects, not just hearing loss, but stress.
Taken together, Darlene believes this combination of hearing loss and stress has very serious implications for marine mammals.
Consider that hearing is a critical sensory system for these animals. It's fundamental to everything that they do. If we affect their ability to hear, if we mask noise with other noise that we're putting in the oceans, even if we don't damage their hearing directly, it's going to impact their ability to survive.
But more concerning is the possibility that ocean noise might be affecting a much wider cross-section of marine life.
Hearing is not an important sense for just whales and dolphins, but for virtually any animal in the oceans. Clearly, if hearing can be affected in a whale and dolphin, if their prey also use their ears, noise could be affecting the prey and its ability to survive too.
Much more research is required before we will fully understand the implications of ocean noise for marine life. But as with other human impacts like overfishing and acidification, it will only be through the power of evidence that we can hope to bring about change. from the cold waters of the North Atlantic to the coral reefs of the Pacific and beyond. The census of marine life has provided us with a unique insight into our oceans, both past and present, a new baseline of knowledge from which to make sense of this most vital of ecosystems. But the census has also given us a glimpse of the future, in which many species and habitats could end up disappearing, some before we've even had the chance to discover them. This is a map of the world's oceans as you've probably never seen them before. It represents the impact that human activities have made on them, from shipping and fishing to pollution and climate change. The redder the colour, the greater the degree of impact. In the seas off Britain, fishing, pollution, the production of oil and gas has turned them deep red. Farther westwards, the colour becomes orange, proof that even thousands of miles away from the continents, man's activity is still being felt. In fact, only very few areas of the ocean surface remain relatively unaffected by human activity. About 4%, like those small patches of blue around the Torres Straits just north of Australia. What this map will look like in 50 years' time, or even 10 years' time, how much redder it will be, depends on how much notice we take of facts revealed for projects like the census of marine life. Until such time, the question of whether it is too late to save the ocean will hang in the balance.
Things are not going to go back to be the way they were, 200 years ago, or even 50 to 100 years ago. But that doesn't mean it's too late.
It's pretty grim. It's pretty grim, and to think it's not grim is self-deluding. But I think that we need to live in hope. Whether it's too late, who knows?
There will be some changes in the oceans in the future, but the magnitude of those changes are somewhat dependent on what we do now. Because we're running out of time. If we don't do something soon, we'll have really dramatic changes that could have really important consequences for the future.
I feel that we're right at the moment where if we go any further, we will not be able to save the ocean, and that will be at great cost to ourselves. But right now, I think we can do a lot. We can just save this place. I mean, it's the heart and lungs of the Earth. I mean, we can't afford to lose it, so we're not going to lose it.
Still to come here on BBC HD Comedy in just a few moments, when you can catch up with last week's Him and Her, followed at past by a brand new episode. And then from 11:15, double US drama with 2 back-to-back damages.